In this video, we will see how to invoke R from within a session of the Geographical Information System QGIS in order to be able to inspect the contents of the vector data in R and subsequently to use R for some statistical analysis of the data. In geographic information systems, the expression vector data means both a collection of objects of a similar nature that can be spatially identified, for example, cities that can be represented by points, roads that can be represented by lines, countries that can be represented by polygons. These objects are called features in GIS jargon. But it also means, vector data also means, that for each of these objects we have a collection of attributes, that is, values of different variables relating to that object. For example, for any given city, its population or size or population density can be provided. Or for roads or railway lines, you may be given their length. Let us begin by introducing some vector data into QGIS. We will use social and economic data relative to the countries of the world, which is provided by SAGE, the Center for Sustainability and the Global Environment of the University of Wisconsin-Madison. Open your browser and look for the QGIS tutorials at qgistutorials.com. Next, look for the tutorial on basic vector styling. There, you are provided with a zip file called lifeexpectancy.zip. Download it and save it in some directory of your choice. Go to the directory where you have saved your lifeexpectancy.zip file and extract this zip file. You will see that besides a README file, which contains relevant information regarding the data set with which we will be working, the vector data for QGIS is also given in 5 different files. These files share a common name, in our case Newsweek_data, but they have different extensions. Both files with extensions starting with the letters SH are associated with QGIS, and they can be opened by just double-clicking on the icon. But instead of double-clicking on the icon, we will open a QGIS session and import our vector data into the QGIS session. Once QGIS has opened, go to the Layer option in your menu toolbar. Select Add Layer, and then select Add Vector Layer, since the data is of vector type. In the dialog box that opens up, where it says Source, click on the Browse button, and in the directory where you have stored your data, select the file with extension .shp, which stands for shapefile. You will be shown another dialog box asking you to select the coordinate reference system. Just accept the WGS84 reference system by clicking OK. You should now see a map of the world that was built using the information regarding the objects in our vector data, which are the countries. And this means that your vector data has been successfully loaded into QGIS. You will remember that GIS vector data is made up of both geometric objects, which in our case are countries represented by polygons, and the information regarding the shapes of these polygons is part of the vector data that came with the zip file. But vector data also has a second part to it, and that is the attributes or variables or factors associated with each object. In our case, this is information regarding each country. In QGIS, the attribute table can be seen by again selecting the layer option in the toolbar and then the Open Attribute Table option. We see that the data table has 165 rows or features, which in our case are the countries. And for each of these features, that is for each country, there is a large number of variables or attributes. Some of these variables are factors, such as, for example, the world region for that country. Others are numerical variables, such as, for example, surface area in square kilometers or the population of the country. In a previous video, we loaded the life expectancy vector dataset into QGIS. We will now see how we can transfer over to R the vector data that was loaded into QGIS. We will write an R script, as is also illustrated in the video on raster data. You should be able to see a processing toolbox panel on the right-hand side of the QGIS window. If not, go to the View option in the menu, select Panels, and then click on Toolbox. That will make the processing toolbox appear on the right-hand side of your QGIS window. Open the R Scripts option, which should be visible inside the processing toolbox panel, and then open Tools. Select the option Create New R Script by double-clicking on it. An editing window will open up where we will write the script. The first few lines in the window must specify the input that we wish to transfer over from QGIS to R, and should that be the case, also the output that we wish to transfer back from R into QGIS. In addition, this header can specify to which of the groups of R scripts in the processing toolbox we wish to add our new script. These initial commands in our window should be preceded by a double hash sign. Let us begin by creating a new group of R scripts called My Scripts. We do this by, after the double hashtag, writing the name that we wish to give to the group, an equal sign, and the word group. So we could write double hashtag My Scripts equal group. Next, we are going to specify what kind of data we wish to transfer over from QGIS to R. We wish to transfer vector data, so we will write, after the double hashtag, the name that we wish to use for the data, I shall call it our data, and then equals vector to indicate that it is vector data. This is all that we need to transfer vector data. From now on, we will write R commands without the double hashtag, commands that will enable us to process the vector data that is being transferred from QGIS over to R. However, we need non-standard R packages. Specifically, we will need a package called SP and a second package called RGDAL. If these packages do not exist on your machine, you must first install them. This can be done from within the script window by writing the standard R command for the installation of add-on packages, which is install.packages. And then, between parentheses, the name of the package that we wish to install. I am working on a machine that already has these packages installed, and so we do not need to go through what is actually a lengthy process. But we will need to load into the R session these non-standard SP and RGDAL packages. And this can be done with the require command for each of the packages. So writing require open parentheses SP close parentheses and require RGDAL will load both these packages into our R session. All that is left to do in order to be able to see the data is to write the name that we have given to our data, which in our example was precisely our data. Beware that in R, upper and lowercase letters are different symbols, so you must be careful to respect the upper and lowercase combinations of letters. We are now ready to run the script. In order to run the script, we must select the cogwheels icon. Pressing on it, we will see how the vector input command has created a little window in which we can select the name of the input data. Since we are working in a directory that only has one shapefile, it is already pre-selected. All we have to do now is click on the Run button. When a script is run, the output that is generated will be passed on to a window, as we can see here. It may be the case that on your machine, the window closes as soon as the script stops running. Should that be the case, click on the Processing option on the menu toolbar, select Options, and under General, click the box to the right of the Keep Dialog Open After Running an Algorithm option. This will mean that the window with the output from running the script will remain visible until we close it. And we can therefore inspect what has been done. After loading the two R packages as we requested, when we ask to see the Our Data vector set that was passed to R, we get information that is visible here. The first line tells us that in R, the vector data has been stored as an object of class Spatial Polygons data frame. This is a special class to deal with vector data of a polygon type, such as the one that we have in our example. Spatial Polygons data frame is a class provided by the SP package that we loaded initially. It is a class of type S4 in the usual R jargon. This means that it is an object composed of several other objects called slots. We will see in a moment how to access these slots. But first, let us look at the other lines of output produced by running the script. The second line tells us that in our example, there are 165 features, that is, the 165 countries that were included in the dataset. There is also a line called extent, giving us some information regarding the latitudes and longitudes in the spatial depiction of our features. And also some information regarding the coordinate reference system that was used. The output of the script also tells us that there are 64 variables, that is, 64 columns in the attribute table of our vector data. And it provides the names of the initial variables as well as the minimum and maximum values for each of those variables. As we mentioned, the Our Data object that has been created in R has slots. If we wish to see the names of these slots, we go back to the script editor and use the command slot names from the SP package. Beware that the N in names is a capital N. So writing slot names and then between parentheses our data and running the script once again, we will see, besides the information that we already had, that our data is an object with 5 slots called data, polygons, plot order, bbox, and proj4string. Should we wish to see the content of any one of these slots, then back in the script window, after writing the name of our object, our data, and the @ symbol, we write the name of the slot whose content we wish to see. So, for example, to see the contents of the proj4string slot, we write our data at proj4string. Running once again the algorithm, we see that slot proj4string contains information regarding the coordinate reference system used in our vector data. In a similar way, we can access any other slot in our object. The data slot contains the attribute table with our vector data. Since it is a big object, 165 rows and 64 columns, we will store it in an R object called att.table. This is the name that we provide. So writing att.table, left arrow, our data at data, allows us to see the nature of this object, which is a data frame. Attribute tables are stored as objects of class data frame in R. And we can ask to see the size of this data frame, as well the names of its rows and columns, by using the standard R commands dim for the size of the data frame and dim names for the names of its rows and columns. Let us run the script once again to see the results. The att.table object is of class DataFrame. It has 165 rows and 64 columns. The names of the rows and the columns are also given in our output window. In a previous video, we saw how to transfer vector data from QGIS to R and how to store the attribute table of the vector data in an R object that we chose to call att.table. We can access any information in this attribute table in the same way that we would access information in any other R data frame. If we wish to see the contents of the attribute table, say for the first country, and we wish to see the value of two variables, say variables name and pop_k, which give the country's name and population in thousands. We can go back to our script and request to see the appropriate rows and columns in our data frame. In R, to select rows and columns of a data frame, we use square brackets with a comma. To the left of the comma, we must indicate the row numbers that we wish to see. And if we are only interested in one row, all we have to do is write the number of that row. After the comma, we will specify that we are interested in 2 columns, and so we must create a vector with the names of the columns that we wish to see. In our example, columns name and pop_k. So we are requesting only row number 1 and the 2 columns with the information on the name and population of the country by writing @.table and then between square brackets 1 and the vector. Running the script shows that the country is the Central African Republic and that its population at the time was 3,430,000 inhabitants. We mentioned that our data object was of class Spatial Polygons data frame. This long name comes from the fact that the attribute table of vector data is stored in a data frame. But the object also contains information on the spatial polygons that are specified to define the borders of each country. We will now see how this works in the R object that is created by the SP package. So back in our example, we will look at the case of South Africa. This is because at the time that this data set was created, the authors had to define the shape of South Africa with 3 polygons. Let us go to the Layer menu option of the QGIS window and then choose the Open Attribute Table option. Looking for South Africa, we see it is in row number 20. If we select the South Africa row, the selection is indicated at the top of the Attribute Table window and is highlighted in the map provided in the main QGIS window. We need the shape of one large polygon to define the present borders of South Africa with the countries of Namibia, Botswana, Zimbabwe, Mozambique, and Swaziland. A second polygon is necessary because there is an enclave in South Africa, which is the country of Lesotho, which must be excluded from South Africa. But the authors of the dataset also included a third polygon to define the shape of South Africa, which corresponds to the then controlled by South Africa exclave of Walvis Bay in Namibia. Walvis Bay has since been handed back to Namibia, but at the time it was occupied by South Africa. So let us see how these things work with the R object, our data. We must first deselect the country of South Africa in QGIS so as to not confuse the R script. We will also close the attribute table in QGIS. Coming back to our script editor, we will first delete some lines that are no longer necessary and proceed to store in an R object called shapes the polygon slot of our data. The plural polygons already indicates that we might need several polygons to define the shape of a single country. Let us request to see the class of this object. The polygons slot is stored by the S package in an R object of class list, which is the most general standard class for R objects. Lists are collections of other objects. We will ask to see how many objects exist in our shapes list using the standard R command length. Running the script, we see that the shapes object is indeed of class list, and its length is 165 because there are 165 countries, 165 features, the borders of which have to be defined. We can see what happens with South Africa by selecting feature number 20 in the shapes list. For lists, the way to extract a component is by using double square brackets. And so writing shapes and then 20 in between double square brackets will give us the information regarding South Africa. Running the script, we see in the output window that the 20th component of the shapes list is an object which has 3 individual polygons. This 20th component of the shapes list is, as we said, an object of class polygons in the plural. It too has slots for individual polygons. So in slot number 1 of the polygons class, we have an individual polygon, which is an object of class polygon in the singular. This object has different information. First, there is a slot called LABPT, which means the point which will be used to label this polygon if a single point is needed. Then there is a slot called area. We see that this is the smallest area of the 3 polygons, and so it must correspond to the Walvis Bay exclave. Then something that will become more apparent later. There's a slot called hole, which has the logical value false in this case. And then there is a slot called coords, which has the coordinates of the vertices that were used to define this polygon. If we look at the second polygon that defines South Africa, we see the label point slot, LABPT, the area slot, which has a much larger value, and again the whole slot with the logical value false. And there is a large number of vertices in the coordinate slot, coord, which suggests that this is the polygon associated with the main part of South Africa. The third component of the polygons object has the value of its label point in area as before, but now it has the logical value true in the slot hole. This is the polygon that corresponds to Lesotho, the country of Lesotho, and which must be excluded from the country of South Africa. And that is why its whole slot has logical value true. The crucial element to keep in mind in this example is that all the information in vector type data, whether the attribute table or the shape data or the coordinate reference system or other information in the vector data, is readily available and can be accessed from within R, as we have seen.